Okay, we've got a couple more people we're waiting to join. It's Friday, guys. Woo! Yeah, it's kind of sunny here right now. Oh, let's see. There we go. Okay, nope. Still just 12 of us waiting on a couple of other people. Okay, we're going to go ahead and get started. And if anybody else joins us while we're doing this, that's fine. But let's go ahead and get started. We're going to go right back into that virtual locker assignment. So up first, so the people who still need to share, now let's see if they are here. The people who still need to share are Fatima and Keon, Mateo, Edwin, and Camilla. Do we have any of them right now? Let's see. Oh, Edwin is here. Edwin, would you be willing to share yours? You got to unmute yourself. Oh, yes, you will. Okay, I'm going to go ahead and share my screen and pull up Edwin's. And Edwin, you'll just unmute your microphone so that you can tell us about your locker. There we are. Okay. Here we go. And present. Alrighty, Edwin. Oh, wait, hang on. Somebody else is. Oh, there we go. Make sure your microphone is on mute, guys, if it's not your turn to talk. Okay, Edwin, can you unmute your microphone? Oh, sorry, that was my bad. Oop. Unmute. There we go. Okay, Edwin, why don't you tell us about your locker?
First, my favorite food like hot wings. And my parents are from Mexico, basically. And I like GTRs, like cars. Like I like learning about cars, like engines or something, like a mechanic.
Very cool.
I go fishing with my stepdad sometimes, like in the weekends, or we go camping every single like 2 weekends when we can. I like math. My favorite sports like dirt bike riding. Like I want to buy a new one, but it's too expensive. So yeah,
Okay.
so, like this little, it's like a cartoon when I was small. So it's like
Yeah.
Pocoyo. We used to call him like that. And I play Xbox with my games. And I have a dog. It doesn't look like that, but he's mixed like with that color. So yeah. And then my favorite like snack is Takis or like Cheetos, something. I don't know.
Like a crunchy snack.
Yeah.
Nice. I like Takis. Just, I don't know. Takis aren't my favorite, but I do like Flaming Hot Cheetos, which are similar.
Yeah, I like those because it's like more like cheesier. I don't know, like more crunchy.
Yeah. Awesome. Great job. Thank you so much for sharing, Edwin.
Okay.
Okay. So let's see. Did anybody else join us? Yes, we've got Keon with us now. Hi, Keon. Would you be willing to share your locker with us? You haven't finished it yet? Okay. Well, you're going to need to get it finished soon, and then maybe you can share on Tuesday. Graham, you want to go? Yeah, let's go. We'll look at Graham's now. Okay. Share my screen. And we're going to exit out of Edwin's. Escape. Let me out, please. There we go. Okay. So let's go find Graham's. Graham's. There he is. Okay, Graham, go ahead and unmute your microphone so you are ready to share.
Can you hear me?
Yes, we can hear you. Whenever you're ready.
Okay, so I like UK. I like Marshmallow. I like my favorite movie is The Meg, so I put The Meg down there. I like listening to Drake. I like football, soccer. I like playing the cello, and I like reading diary with a kid, and I love hockey.
Awesome. Do you have a favorite hockey team?
No, not really.
Hey, that's okay. That's okay. I'm also a new hockey fan. My older brother loves the Toronto Maple Leafs. He loves that team. So I'm trying to get into hockey more and watch it. Cool. Thank you for sharing, Graham. Okay, who else do we have? Hello. Welcome back, guys. Okay, a couple more people joined in. Hello. Welcome back, Elise. There's Riley again, being so polite and being a good classmate. Thank you, Riley. Okay, thank you to everybody who shared today. Let's see. So Keon, you're gonna share next week, okay? And then Mateo isn't with us right now, is he? Nope, Mateo's not here right now. And Camilla's not here right now. So we will catch up with them later. We'll check out their slideshows next week, probably on Tuesday, hopefully. Okay, guys. So it's Friday. So we're not going to do a whole big lesson, but what we are going to talk about is the scientific method. Okay, and we talked about that a little bit yesterday when we did the Nearpod about science in general. Okay, so we're going to talk about the scientific method. We're going to watch a brain pop about the scientific method, and then we are going to take the quiz at the end of the brain pop. And the way we will do that is I'm going to show the questions on the board behind me, and then you all are going to type your answers into the chat, and we'll showdown so that we all send our answers to the quiz at the same time. Okay? So the brain pop is about the scientific method. You need to be listening for the correct order of the steps in the scientific method. You need to be listening carefully for vocabulary words like theories and hypothesis. Okay. So just be listening carefully. I don't know why we're missing so many people right now. Could be an internet issue, could be another issue. But the important thing is that you all are here. You all showed up ready to work. So that is what's important right now. So get your brains ready. I'm going to pull up the brain pop behind me. And here we go. Okay. Just another reminder, guys, there is no school on Monday, so don't show up ready to work on Monday because that is your day off. Now there are 15 people here. Yes, welcome Camilla, welcome back. Glad to see you. Okay, so I'm gonna go ahead and spotlight my screen and I'm gonna dim the lights so that you all can see that better. Alrighty. Brain pop, scientific method. Here we go.
Yeah, I know you've been watering it. I'm not sure what's wrong. Dear Tim and Moby, what is the scientific method? From Marcy. The scientific method is the procedure scientists use to help explain why things happen the way they do. When people are trying to understand the world around them, they often come across problems that they just don't know the answers to. This is where the logical, step-by-step method of scientific problem solving comes into play.
Okay. That's not working all that well. I'm going to do it on the computer and just share my screen with you. And then we'll use the projector for the quiz. So we'll just watch the video on our computers because that's way too loud for me, but you all probably still can't hear it very well. So let's do it this way. This way's easier. All right, here we go. Round 2.
Yeah, I know you've been watering it. I'm not sure what's wrong. Dear Tim and Moby, what is the scientific method? From Marcy. The scientific method is the procedure scientists use to help explain why things happen the way they do. When people are trying to understand the world around them, they often come across problems that they just don't know the answers to. This is where the logical, step-by-step method of scientific problem solving comes into play. Like Moby here, he seems to be having a problem with his plant. The first step in scientific problem solving is to recognize the problem. Right. The plant is dying even though it's getting water every day. Why? To solve this problem, we first need to understand what we already know. Okay, plants need water. What kind of plant is that? Fig tree, right. Now we need to make some observations about the plant. The leaves are brown and falling off, and the soil is wet and squishy. Next, we make an inference. An inference is a conclusion about our observations. From what we've observed, we could infer that Moby is watering his plant too much. Now we translate our inference into a hypothesis. Well, a hypothesis is a testable explanation for the details you observe. What about fig plants do best if you only water them once a week? Sure, it's just a guess, but after our observations, at least it's an educated guess. We'll need to come up with an experiment to test this hypothesis. Here's the plan. We've got 4 healthy fig plants marked A, B, C, and D. They have the same type of pot, the same soil, and they're getting the same amount of sunlight. The only variable or thing that changes will be the amount of water they receive. Plant A will not be watered at all. Plant B will be watered every day. Plant C will be watered 3 times a week. And plant D will be watered just once a week. We'll check back in a month to see what's happened. What do you know? It's been a month, and I'm still wearing the same shirt. Let's record new observations. Plant A doesn't look too good. Plant B doesn't look so hot either. Plant C looks a little better. Whoa there, plant D is doing all right. Time to analyze our data. Based on this experiment and our observations, it looks like the fig plant did best when it was only watered once a week. From that, we can make a conclusion. Of the 4 watering schedules we tested, fig plants seem to grow best when they're watered once a week. Well, yeah, to be really sure, we should repeat this experiment several times just to rule out accidents and variables we may have forgotten to consider. If the experiments don't support the hypothesis, then the hypothesis has to be rethought. Back to the drawing board, so to speak. But if lots and lots of experiments do support the hypothesis, then that hypothesis can eventually become a theory. Well, in science, a theory is an explanatory statement that's been repeatedly confirmed through experimental testing. If a theory is proven valid over and over again, it becomes an accepted piece of scientific knowledge. In the strictest sense, there's really no such thing as scientific fact. Scientists are always learning new things about the world around us, and you never know when they may find some new bit of evidence that forces us to redefine our understanding of the world. Right, using the scientific method can help you be right more often, and not just in science class. You just have to make sure you do all the steps. If you form a hypothesis without making any observations, then you really are just guessing. And you'll never know if your hypothesis is true or not without testing it with an experiment.
Okay, so there were lots of important words in there. So I hope we were listening. Some of those important words were hypothesis, experiment, observation, theory. Okay. I don't know why his shirt is a clipboard, but I think that's pretty cool. I'd wear a shirt with a clipboard on it. I think that's kind of funny in how plain it is. Alrighty, guys. Inference. Inference was another one. Yeah, very good. Can anybody think of any other ones that I missed? So we had theory, observation, hypothesis, inference, experiment. Anything else? Any other words I'm missing that popped out at you? Conclusion. That's a good one. Great. Anything else? Okay, let's take the quiz. So again, we're gonna take the quiz on the board, but you are going to send your answers into the chat using Showdown. So don't send your answers until I say Showdown. Otherwise, everybody in the chat can see your answer and might just copy yours. So if we do it Showdown style, everybody sends it at the same time and nobody can change it real quick. It also isn't for a grade or anything. The quiz is just to see what we think and what we know and what we remember. So that being said, let's give it a try. We're going to do this one. All right, question number 1. What is the difference between a hypothesis and a theory? So what is the difference between a hypothesis and a theory? So is it A, theory is another word or fact? Oh, for fact, hypothesis is another word for guess. B, hypothesis can't be proven, theories can. C, theories have been confirmed through tests, hypotheses have not. Or D, theories contain many hypotheses. A hypothesis only contains one theory. Which of these is the best description of the difference between hypothesis and theory? So go ahead and don't send your answer, but get ready to send your answer in the chat. There we go. All right. So let me see those answers in 3, 2, 1, Showdown. Okay, we've got a B, C, D, D, B, D. Hey guys, let's stop changing our names, okay? Because A, that's distracting, that's not staying on task, and B, you spelled Kobe's name wrong. So, all right. So the correct answer here is that theories have been confirmed through tests and hypotheses have not. Alrighty. So good job if you said C. Moving on to number 2. Number 2 says that, oh, it's so hard to see the screen. Number 2 says, place the following steps in sequence. So this is putting the steps of the scientific method in the correct order. Okay, so we've got A is recognizing a problem, B is testing a hypothesis, and C is drawing inferences. So what would be the correct order of those 3 steps? what would be the correct order of those 3 steps? So again, A was recognizing a problem, B was testing a hypothesis, and C was drawing inferences. Okay, so A says A and then C and then B. Choice B says A and then B and then C. Choice C says B, then C, then A. And then choice D says C, then B, then A. So what is the correct order of these? Okay. Let's see those answers in 3, 2, 1, showdown. Okay, so everybody said B, A, B, C. But actually, when you're doing the scientific method, the way it goes is A is first, yes. So recognizing the problem, that's first. But these two should be switched. So it should go drawing inferences and then testing a hypothesis. So it should actually be A, C, B. Okay, the phrase, the scientific method is an analytic process for determining why things happen. What's the best synonym for analytic? Okay, this one's a hard one, so I'm just gonna go ahead and tell you it's logical. Analytic basically means logical, okay? Let's see, number 4. What do you do before you make a hypothesis? Okay, this one we should be able to get. What are you supposed to do before you make a hypothesis? A, run an experiment. B, make observations. C, form a theory. D, draw conclusions. What comes before you develop that hypothesis? Which of these would come before you develop that hypothesis? So would you run an experiment before you develop a hypothesis? Would you make observations? Would you form a theory, or would you draw conclusions before you develop a hypothesis? All right, let's see those answers in 3, 2, 1, showdown. Okay, let's see these answers. Okay, I'm seeing most people are saying either B or C for the answer here. And the correct answer here is make observations. Before you can develop a hypothesis, you've got to make those observations of things you notice in the world. Okay, if you were running an experiment to determine the temperature at which beans sprout the fastest, what would be the variable? Okay, so remember, the variable is the thing that changes. It varies, so it changes. So which thing would you change in this experiment? What would be the thing that is changing in this experiment? Graham, Riley, guys, I'm gonna have to turn the chat off here in a minute, okay? All right. So if you were trying to determine what temperature would be the best for sprouting beans quickly, what would be the variable in that experiment? So is it A, the number of beans you plant? B, the height of the sprouts you grow? C, the amount of water you give the beans? Or D, the temperature at which each bean is kept? Which of those is going to be the thing that changes? Okay. All right, let's hear those answers in 3, 2, 1, showdown. Okay, I only got a couple answers here, but I got some C's, some B's, and then 2 people who said D. Oh, another D, another D. Oh, okay. Sorry about that. Sorry you guys aren't hearing the answers. So the correct answer here is actually D. It's the temperature at which each bean is kept. That would be the thing that is getting changed in an experiment where you're trying to figure out the best temperature for sprouting beans. Okay. All right, let's go on to the next one. Okay, so you should run an experiment several times to make sure your results are consistent. Okay, in the preceding phrase, what does consistent mean? So what does the word consistent mean? Okay, so this question is saying that you should do an experiment many times to make sure your answers are consistent. Okay, so what does the word consistent mean? Does it mean A, obvious, B, perfect, C, unchanging, or D, testable? Which of those words is the correct synonym or definition of the word consistent? So A, obvious, B, perfect, C, unchanging, or D, testable? What would be the correct definition there? All right, let's see those answers in 3, 2, 1, showdown. Okay. So let's fix this. There we go. This just feels easier to see. Okay. So those answers, most people said C or D. So the correct answer here is C, unchanging. Okay, if something is consistent, that means that it's pretty much the same every time. Okay, so that means it's not changing. Number 7, everybody should be able to see the questions and everything now. All right, so what might cause a theory to change over time? What might cause a theory to change over time? A, new laws passed by the government. B, new but untestable ideas. C, changes in public opinion. Or D, the discovery of new evidence. Which of those might cause a theory to change over time? Okay. Let's see those answers in 3, 2, 1, showdown. Okay. All right, most people said D. Yeah, new evidence. New evidence would be able to change a theory over time. Okay. New but untestable ideas would not change a theory. Changes in public opinion. Opinion has nothing to do with a scientific theory, and new laws passed by the government. The government can't make a law that changes science. They can make laws based on science, but a law can't change science. Evidence and facts, real evidence and facts and information is the only thing that can really change science and scientific theories. Okay, we're almost done here. We've got 2 more questions after this. So evolution is one example of a theory. From what you know about the scientific method, what can you conclude about this biological theory? So if evolution is an example of a theory, what would be true about that theory? A, it's been tested many times. B, scientists don't need to test it anymore. C, no one is allowed to test whether it's true or not. Or D, there is very little evidence to support it. So if evolution is an example of a theory, which of these is true about that? Based on the definition of what a theory is. which of these would be true about it? All right, let's hear those answers in 3, 2, 1, showdown. Okay. Okay, guys, so those of you who said D, there is very little evidence to support it. From what we know about theories, right? In order for something to become a scientific theory, it has to first be something that is observed. There has to be a hypothesis. There has to be many experiments. Okay, and those experiments have to be consistent with the same answer every time, multiple times, before it can become a theory. So saying that there is very little evidence to support it doesn't really make sense, right? But saying that it has been tested many times, that's the correct answer. So A is the correct answer there. All right, number 9, which of the following is a testable hypothesis? So which of these hypotheses are ones that we could actually test? Okay, so this is really more based on the difference between a fact and an opinion. Okay, so a difference between a fact and an opinion is going to help with the answer here. So which of these is a fact, a hypothesis, well, not a fact, but something that we could really test, something that we could really do an experiment for, okay? So it can't be someone's opinion. All right, so is it A, roses are more beautiful than violets? B, a plant needs at least 5 hours of sunlight per day to grow? C, ice cream is delicious? Or D, humans will someday land on Mars? So which of these is an example of something we could do an experiment to figure out? Which of these is a testable hypothesis? Go ahead and type your answer, and 3, 2, 1, showdown. No, we're not looking for an opinion. You can't test an opinion. You can't prove an opinion to be true, because opinions at their core are not facts. They are the opposite of facts. They are what people think. Okay, so the correct answer here should be B. Okay, saying humans will someday land on Mars isn't really a hypothesis as much as it is like a goal or a prediction of something that might happen, okay? Alrighty, so last question. What happens if you test a hypothesis multiple times and the data doesn't support your prediction? So let's say I predict that a plant actually needs 7 days of sunlight, okay? But the data does not support 7 days of sunlight. So what happens if I test that hypothesis multiple times and it just doesn't get the answer that I wanted? So do I A, change the data to support my prediction? B, run the experiment again until you get the results you're looking for? C, conclude that your hypothesis cannot be proven? Or D, rethink your hypothesis? What do you think? Which of these is the most logical thing to happen if you do a bunch of experiments to test a hypothesis and none of your experiments get the results you wanted? What do you think you need to do? Go ahead and type that answer and send it in 3, 2, 1, showdown. Oh, guys, okay. I've got some C's, some B's. Okay, 1D. Okay. If you said D, congratulations, you are correct. If I say I think, not I know, I think that it might take 7 days of sunlight to get this plant to start growing. And then I do the experiment a bunch of times, and none of those times does 7 days work. Well, then I don't need to conclude that my hypothesis can't be proven or change the data. I can't do any of that. I just need to rethink the hypothesis and maybe try a different number of days or something like that. So let's check our answers. Oh, and that was the end of it. Okay, guys. Thank you all for participating. And I hope that you have a wonderful weekend. Before anybody goes anywhere, though, let me just see your beautiful faces. Remember, no school on Monday. I will see you Tuesday at 8. Don't be late, okay? You can take your microphones off to say goodbye if you want. I hope you all have a great weekend. Bye. Oh my goodness. Have a great weekend, guys. Have a good weekend.
Bye, Miss Schwab.
Bye, Jackson.